was when the balloon was small? Well, now that the universe is inflated, all the clumps have got bigger. That's all I'm trying to demonstrate. So that's how to think of it. There's no center to the universe. There's no place that the Big Bang started. Now, I don't understand this, so don't, please look as puzzled as you want, because I am too. But the Big Bang started, it wasn't an explosion. There was no noise. There couldn't be noise because there was no matter. There was nothing to make noise with. Matter of fact, there was no space for any matter to be in because there was no space either. Everything was crammed in that one tiny space. But then everything blew up, and all those little tiny clumps became great big huge clumps. So at a certain point, the clumps became the size of fundamental particles like quarks and electrons. Then they became the size of atoms, then molecules. Then they became the size of, well, stars after 100 million years. And then after that, galaxies. And that's how we got here. Those little tiny clumps that were there to begin with expanded as the universe expanded, just like that balloon. And that's why we've got all the structure in the universe. There you see it, okay? As the universe spreads out, the clumpy parts get clumpier, the non-clumpy parts get emptier. So you start out where everything's almost the same, and then you end up there. So the universe expands. Just remember that as it expands, things are getting colder. And by colder, I mean they're only a few quadrillions of a degree. I mean many quadrillions of degrees. So the universe is expanding. We're going to cut it short. Bosons, which you know, now appear. And the Higgs boson shows up and gives everything mass. It was predicted in 1964. It was discovered in 2012. We were watching the program. I think this is where we show oh yeah, Penzias and Wilson. Pigeon poop. These two guys were working on the horn antenna there in New Jersey, I think it was, back in 1964. They were working with weather balloons and satellites. They kept getting interference. So they went up and they trapped all the pigeons. They cleaned all the pigeon poop out. But the interference persisted. And this interference was coming from all over the place. And it was coming from a very long time ago, it seemed. So they phoned up some guys over at Princeton who were working on a thing called the cosmic microwave background. And those guys said, well, you've discovered it. We've been looking at it for all these years, and you buggers have just stumbled on it. Anyhow, that's what it is. Now, it was predicted when the Big Bang was first predicted, it was said there should be something left over from when that happened. And what happened was, actually, I shouldn't tell you this quite yet. Sorry. Yeah, no, they were working, well, okay, 1964, these guys are working in Princeton, New Jersey. What they've discovered is evidence of the Big Bang. Because, sorry, I'll get to that in a minute. I jumped ahead, I shouldn't have. What I'm going to tell you now is we got the bosons, we got the Higgs boson, particles are forming, they're getting mass. This is the quark epoch. In the quark epoch, quarks. All a quark is a fundamental particle. So is an electron. If you put three quarks together, you get a proton. If you put three quarks together in a different way, you get a neutron. That's all you have to know. Protons and neutrons are the nuclei of atoms, and electrons are what go around the nuclei. So quarks are fundamental particles that were created early on in the universe. They're really tiny. They can't be split up into anything else. They're fundamental, just like electrons and neutrinos. And they're what go together to make up the nuclei of atoms, and we're all made up of atoms. And all the universe that we can see, everything from whales to stars to us, is all made up of atoms. That's called baryonic ordinary matter. The other kind of matter is fermions, bosons. They're the ones that make it all work. So regular matter and bosons. Okay, quarks then are made here. Then after that, and by the way, as matter's being created, so is antimatter. Antimatter. That was predicted by our friend Paul Dirac back in 1928, the guy that gave the boson its name. He said they're going to discover this stuff called antimatter, and they're going to discover stuff called antiprotons and anti-electrons, and 4 years later they did, and he got a Nobel for it. So you've got quarks. They're the fundamental particles that make up nuclei. The quarks are surrounded by electrons, and all these things are out there forming, and they're all annihilating each other. Literally, for every 1,000,000,001 quarks, there's 1,000,000,000 antiquarks. 1,000,000,001 quarks, 1,000,000,000 antiquarks. So that there's one left when the annihilation ends. So things were annihilating like crazy. And finally, at 3 minutes after the Big Bang, one of the biggest things in the history of the universe happens. Things get cool enough, they're down below 1,000,000,000 degrees. Things get cool enough below 1,000,000,000 degrees that the first atomic nuclei can form. And all the atomic nuclei form in about 3 minutes. All the atomic nuclei that were ever going to form in the universe and make the first two elements, hydrogen and helium, they all formed in 3 minutes. Because before that it was too hot, after that it was too cold. That was the window. So, by the end of 3 minutes, you've got the protons and the neutrons, you've got the quarks coming together as protons and neutrons, and the protons and neutrons coming together as nuclei. And these nuclei form the nuclei that will become atoms 380,000 years later. By the way, these things kind of show you how everything, right here we are, everything's one. You can see how it's expanding. You can tell how old the science is by what they say. Let's just see, when does it say stars formed? There. I can't see. Anyway, things have changed a lot in the last few years. A lot of things are really dated. Anyway, what we've got now is nuclei. I know. Let's show the periodic table and show that. Oh, I'll tell them how about, oh yeah, Penzias and Wilson, cosmic microwave background. Okay, so those two guys were working. They discovered the cosmic microwave background. Let me take you back. Imagine you're driving along in your car with your parents. You're in the back seat. It's many years ago. Maybe you guys never went through this, but we had to. I'm old. Driving along late at night looking for a motel or something. You got the radio on. And between stations, you get the static. Well, we never used to want the static, right? You wanted the radio station. But the static is the best part. Because it turns out that some of that static you hear between those stations on the AM is the cosmic microwave background. It's there, and you can hear it over that radio. There's a young lady back there, I think her name's Laisa. She interviewed me. She's really cool. She had some good questions. And she said, why are you doing this? And I started babbling away like an idiot about, wonder or whatever. But when I think of something like that, it really does give me, I get goosebumps all over my body. Let me tell you this. Imagine you're listening to something that happened only 380,000 years after the Big Bang. That's 13.787 billion friggin' years ago. You can hear it on your radio. Right? Let me tell you another neat thing. In 1969, a meteorite fell near Murchison, Australia. So they did an analysis of the meteorite. There are in that meteorite things called pre-solar grains. And remember I told you about half-lives and how you can radioactively date things? Well, they dated these pre-solar grains. Some of them are 7.5 billion years old. That's 3 billion years older than the Earth. And it was found right on this Earth. So when Lacy had said, well, why do you do this kind of stuff? And I was trying to say, well, it's kind of wonderful. When I think of holding in my hand something that's 7.5 billion years old, that fills me with, I don't sure call it wonder or whatever, but it's fantastic. And that's why I care about this stuff. So anyway, there's the cosmic microwave background. You can hear it. So what happened at 380,000 years was you got your first atoms. Quarks in the middle, electrons going around, improbability clouds. That's how it works. And so all we have to do now, and I've got 2 minutes, I'm going to tell you about how the solar system started. Maybe I'll tell you that next week. But you might not come back after what I just did to you. I really am sorry. I know that was a lot of stuff. Yeah, basically we got 1 minute, so I think we can go through the solar system in no time.
Tell us about the stars.
Oh, the stars, okay.
Yes.
So at 380,000 years after the Big Bang, you got your first atoms, right? The universe is still expanding like crazy. As it expands, those clumps get worked on by gravity. So the part that gravity is working on, the clumpy parts, they get compressed and agglomerated into certain confined areas. So after the universe has gone on for 100 million years or so, so we're looking at a considerable period of time right now, the universe has spread out enough and become clumpy enough that the clumpy parts have got hot enough to undergo nuclear fusion. So you got to get a temperature of around 10 million degrees to get nuclear fusion. So once things have been mashed together enough, you get stars firing up. And I will tell you more about stars at another time because they go through lifetimes just like people do. And like some people, they blow up. And when they do, they change the universe. This is where we do our periodic table magic, and then we can call it quits for the night. Periodic table. Let's have a look at the periodic table empty. Please?
I'll try.
Good job for me, you've basically memorized it. Okay, that's what the periodic table looked like before 380,000 years ago. I could have done chemistry. You know? I wouldn't have had to go to summer school. That's how it looked up till 380,000 years. Now let's look at it, the one with the 3 elements, please. I think it's number 40 or 41. That's what it looked like at 380,000 years. Now, the stars fire up, and we're going to look at it. What did the stars do? Let's look at it again.
You want it full?
Please, sweetie. Well, whatever number the full periodic table is, there it is. That's what the stars did. Before the stars, basically 2 elements. What did the stars do? They converted the hydrogen to the helium and then not very much boron. Boron tends to disappear like beryllium. But carbon, nitrogen, oxygen, what happens is as the stars get to the end of their lives, what a star is doing is it's fighting a battle with gravity for its whole life. Gravity is trying to squash it, and it fights back by firing up and becoming nuclear. So the stars fight gravity by turning hydrogen into helium. Once they've used up all the hydrogen, they got to turn helium into the next thing up. And each time you turn it into the next thing, it becomes less and less efficient. So for small stars, the size of our sun, it's never going to make anything more than that. And when our sun dies, which it will in another 5.5 billion years, it'll become a red giant. It'll swallow the solar system, most of it. But we don't care, because Earth will have been rendered uninhabitable long before that. That's 5 billion years in the future. Life doesn't even have another billion years on this planet, because a bunch of other things are going to happen before that. That's how the sun will end up. And I think that's just about it for tonight. Is there anything else I should tell them? Let's call it quits. We'll do, the formation of the Earth won't take very long. Honest to God, I can do that in 15 minutes, no problem. But then we're going to have to do, well, I just hope you found it interesting enough that you'll come back. That's all. You know, oh, I had to tell you one thing. Einstein. You've heard of Charlie Chaplin, right? Okay, the 2 most famous and popular men in the world, probably back around 1930, were Chaplin and Einstein. Einstein's the only famous scientist who's ever done that. Well, they finally met. They'd always admired each other. And Chaplin said to Einstein, Einstein said to Chaplin, you know, I've just always admired your work because you don't say a word. Remember, he was a silent guy, right? He never spoke. But everybody knows what everybody understands you. And Chaplin said, well, yours is the greatest glory. He said, because nobody understands you, but they love you anyway. So with that, I hope you'll come back next week. Any questions? Sorry. Okay, well, I hope I'll see you again.
Time for refreshments.
Thank you.
You're welcome. I hope it wasn't quite as incoherent as it seemed to me.
Well, it didn't seem incoherent to me, but I know the whole process. So.
Yeah, right.
So, oh, hey! I didn't know you were here.
Hey, yeah.
Oh, because I wanted to say, I was, if I thought you were coming out, thank you for the
Thanks for coming out, man. I wasn't, I didn't want to do anything to make you feel pressured, so I just stayed out of it.
No, it was awesome.
Huh?
Well, no, but it is kind of. Like a parchment.
It's been a long time since I did this, you know, but I'll get back into the swing of it. Hi there.
I recognized
Oh,
you.
thank you very much.
And I was
Well,
gonna ask
yeah, I'm
you,
glad
did
you
you
came
print it
out.
on, or did you take a picture on
Did you?
spring equinox?
This?
Oh, good.
You know what? I
Yeah,
cannot
well, I
remember
really
when I
appreciate
took that, but I thought, oh my gosh, it's so gorgeous.
Yeah, not bad.
It's years old.
Oh, is it?
Yeah.
Because that's kind of.
Yeah,
what it
it's
was like
okay.
at
I mean,
spring
the thing
equinox.
is, it's
Yeah,
kind
it's
of a topic that probably
just
scares some
gorgeous.
people
So.
off.
It is gorgeous.
Oh God, it's so nice to see.
I'm trying to make it as
you.
unsciencey as I
So
can.
Sharon,
I mean, a lot of people are curious about it.
Yeah. Well, I think I'll satisfy their curiosity. We'll be in a life next week, so theories of early life and all that kind of stuff. It's hard to talk about in a way because it's so far back, nobody knows for sure what anything is like, right? Yeah. So the hard part is like the easiest thing to do would just be a textbook and just teach all that, right?
yeah,
Like you do at school. It's a snap. But with this, I didn't want to use a text because science is advancing so fast that most of the texts are out of date. Right? Like even the most advanced text, like I got a text, I got this book out right here. Except I got a bigger version. We bought this ourselves. And this was put out, I think it was the 2000.
Oh, wow.
But, that means that makes the research.
But I thought,
I won't bug him.
That's a really good book. I mean, the guy did a great job.
So we made the
Yeah.
connection.
But
Me too.
the problem
That
is,
was-
it's so
that was
much dated. I want to
really
give
good.
people,
but I,
like, there's two versions of the solar system. And if I give you the older version, they're gonna give them wrong. Again, if I looked in a book, that would be the version.
I had descriptions on
I better
it.
go next. I'm glad you're here. That's so cool. Thank you very much. Yeah, please.
Yeah, sure.
Awesome presentation.
Thank you.
Yeah.
You ever think of like doing like a show or
Yeah.
something? Like doesn't even have to be related to the Big Bang. I feel like you can find any topic and like you would be able to present it in a comprehensible and also entertaining way.
Hopefully. Yeah.
So here's
You
what.
can make a lot of money off of that.
From where we are.
Oh,
And you can see
Theoretically,
how
if you
probably
get
increase-
good topics and you do your
increase it at
marketing
least,
right, theoretically,
You know,
yeah.
like 50%. See how much space there is from
That
the
makes it
bottom
even
of the
better,
slide to the
actually.
bottom of the.
so you want me
It,
to
it
move
does, it
them
does.
up
Because like if a
higher?
youngster
And make
sees
it bigger.
sees
I think you
you
might have to
explaining
pull it
things the way
out.
that you
Yeah,
do,
Maybe that might not
then
work.
like that makes it a
Can you
lot
see
more
how much space
interesting,
there is
especially
from the
if you're
top of the
explaining
slide to
something
the
that
top
like
of the whiteboard?
that usually
bottom
people
of
don't
the
attribute to
slide.
Oh,
young
right. Okay,
folks,
so I
like-
should move it up.
I don't know,
Well,
food for
I
thought.
was very
All I'm saying is
distracted by the
you're
fact
good at
that,
explaining stuff and you're
it was
entertaining
light
as well.
and.
People that are good at one are usually not good at the
If you make
other,
this
so
bigger,
you've got
it
both
has the
down,
area where you
so.
can notes.
I hope to be able to make it
Next time
next
I
week.
can do that.
Can it?
You might.
If you end up.
Oh,
Good,
yeah.
good, good.
You might have to
Yeah.
No, I worked at the paper previously,
Yeah, I think with
so
the
Lisa
lights,
told me
yeah,
about this and I was like,
Oh, okay.
oh, okay, that's awesome. Let's see if I can make it. I didn't make it, so
Well, thanks for
hopefully I
coming
can
out.
make it next week.
I mean, it's not easy coming out after work.
Oh, yeah.
Right, it's a drag, so I appreciate you pulling yourself out. Thanks.
I'll see you around, sir.
Yeah, thanks, Ken, right?
Nope, that's me.
Yeah, okay.
I don't think we're actually living longer than anybody did back in
Yeah, an audio file and
their lifespan was so now we're living to
But this one here, I had a little
but I don't think we really are.
So we'll,
Time, like the time is actually lengthening,
no, I know I.
right? Yeah.
Do you think time is lengthening?
Yeah, I think it's, no.
Oh,
Sorry, no, it's the other way
Like
around.
time,
It's getting shorter, so our years are actually shorter than they were before. So we're living the same, actually the same length of time.
yeah.
Because it's, the time is
Anyway,
shortening up,
I'm gonna go
it's
for
going
the
faster.
I'm
Time's going faster.
going
It's faster. Time goes
Yeah, but
faster.
time isn't going faster as it expands. I think.
She lives in Warren.
Time is, like what Einstein showed was that time is a variable. So, like right now, it just occurred to me the other night, as a theory, so I looked it up and I was right. But I was sitting there And I was thinking, okay, like, when time passes by, a